Hey everyone, welcome back to my channel, The Daily Scope the Universe. Dose and T operate on our schedule, while we build rockets, plan missions, and stare at screens counting down to liftoff. The sun keeps spinning, unpredictable and powerful. June 19th was supposed to mark a routine yet historic milestone, the launch of Axiom mission but just when everything appeared perfect, a violent solar event unfolded 93 million miles away. A massive solar flare, unseen by the naked eye but deadly in its intensity, disrupted every calculation. Every plan, every dream tied to that mission. This wasn't just about a delay, it was about survival. Hidden behind official statements and carefully worded press releases was a scramble unlike any other. Engineers raced to understand radiation models. Space weather scientists issued emergency briefings. And astronauts, trained to face countless threats, were suddenly staring at an invisible enemy, one they couldn't see, dodge, or fight. The sun had spoken, and humanity had no choice but to listen. What makes this moment so terrifying isn't just what happened, but what almost did. How close did we come to launching into a storm of lethal radiation? What does this mean for future missions to the Moon, Mars, and beyond? Let's break down the full truth of what's really happening in space right now. NASA's Axiom mission for WASN-T, just another launch on the calendar. It symbolized a new era of private-public space collaboration. Astronauts from different nations, private funding, and advanced tech all came together to make it happen. Yet as the world focused on countdown clocks, something unseen triggered concern behind the scenes. Space weather monitoring centers picked up intense electromagnetic fluctuations originating from a volatile sunspot region. These were early indicators of a solar flare. And not just any flare, but one strong enough to endanger electronic systems, astronauts' health, and spacecraft shielding. SpaceX engineers and NASA officials convened emergency meetings. They halted final checks. Radiation readings were analyzed. It became clear the sun wasn't cooperating. For the safety of everyone on board, the mission was delayed. But outside the control room, the public only saw a brief announcement, not the full scope of what almost went wrong. Solar flares aren't just impressive bursts of light. They are cosmic eruptions of deadly radiation. The flare recorded on June 18th was classified X1.2, among the most extreme on the solar scale. This kind of flare isn't just bright, it shoots charged particles through space at immense speeds, capable of penetrating even the best spacecraft shielding. For astronauts outside Earth's magnetosphere, this exposure can be lethal. The timing couldn't have been worse. The flare erupted just as the Axiom 4 launch team prepared for final systems integration. Emergency alerts were triggered globally. Real-time data from the Solar Dynamics Observatory showed not only the flare, but a likely coronal mass ejection heading toward Earth. That meant hours later, radiation levels would spike. A launch window during that time frame would have put the crew directly in harm's way. It wasn't just smart to delay, it was vital. How exactly do solar flares disrupt space missions? First, they interfere with onboard electronics. Imagine launching a spacecraft and suddenly losing navigation, communication, or thermal control. Second, the biological risk to astronauts is immense. Our planet's atmosphere and magnetic field protect life on Earth, but in orbit, there is no such defense. Without heavy radiation shielding, human cells can be damaged within minutes. That's why space weather centers like NOAA and NASA's Space Radiation Analysis Group constantly track solar activity. Even a small error in timing could have led to catastrophic failure, not just of the mission, but of lives on board. The sun doesn't warn us, it reacts. And this time, its warning came just in time to save a crew from facing its fury head-on. The history of solar storms is scarred with near misses and disasters. In 1989, a geomagnetic storm caused a blackout in Quebec. In 2003, a flare disrupted GPS and satellite communications worldwide. But the granddaddy of them all remains the 1859 Carrington event, the most powerful solar storm ever recorded. It set telegraph lines on fire and lit up skies with auroras as far south as Cuba. If a flare of that magnitude occurred today, experts believe it would knock out satellites, fry electrical grids, and cripple global communications for weeks or months. The June 19th event was that severe, but it was enough to shake the confidence of mission planners. And with solar activity expected to peak in the coming years, this won't be the last disruption. Not just at the mercy of nature, we vulnerable to it in ways we barely understand. NASA and private space companies are already developing next-gen protective technologies. Advanced shielding, radiation forecasting AI, and even emergency safe zones within spacecraft are in the works. But these systems are expensive, complex, and not yet ready for every mission. For now, decision-makers rely on fast communication, predictive models, and gut instinct. The Axiom 4 crew, which included veteran astronaut Peggy Whitson and an international team, were briefed, grounded, and kept out of the spotlight. Their training prepared them for emergencies. But cosmic radiation is a different beast. You can't fight it, you can't fix it, you can only avoid it. That's what makes this moment so profound. The best minds in science stepped back and admitted that waiting was the only smart move. There's also the political side of space delays. Every scrubbed launch costs money, time, and credibility. Investors, partners, and government agencies demand explanations. But how do you explain that? A star, the same sun that gives us life, forced your hand. That the mission was perfect on every technical level, but nature refused to cooperate. It's humbling, and it shifts the narrative of control. We like to think we dominate the skies, but one rogue flare reminds us who really holds the power. As space travel becomes more commercialized, expect more delays like this. The sun doesn't care about business deals or press conferences. Still, the delay offers valuable lessons. Teams are now reviewing solar flare protocols, adding layers to launch go, no-go checklists, and even reconsidering launch windows based on solar activity forecasts. Some experts are pushing for dedicated solar observatories at Lagrange points to monitor flares in real time, a costly but possibly mission-saving investment. Others suggest developing automated abort sequences triggered by sudden radiation spikes. Either way, the game is changing. Our expansion into space is now fully dependent on our understanding of something we can't touch, predict, or control. The public might see this as just another delay, but make no mistake, this was a narrow escape. Had Axiom 4 launched on schedule, the crew might have flown directly into a radiation storm. Best case scenario: damaged electronics and communication blackouts. Worst case, less risks to the crew and a compromised return trajectory. This is no exaggeration. We've entered a phase of space exploration where solar weather is just as important as Earth weather. And with missions planned to Mars, which requires 6 months of unshielded travel, the stakes are only going to rise. Even now, mission planners are adjusting. A new launch window will be chosen based on updated solar forecasts. Crew health is being reevaluated, and confidence is being slowly rebuilt. It's a moment of reflection, not regret. Because in space, the line between success and tragedy is razor thin. Every decision must be perfect. Every delay must be justified. This time it was. The world moves on, slightly more aware of just how fragile our cosmic ambitions really are. If you've made it this far, you now understand just how powerful and dangerous our sun can be, and how even the most advanced space missions remain at its mercy. Space is beautiful, but it is also unforgiving. If you found this breakdown eye-opening, hit that like button and subscribe to the Daily Scope for more real-time space updates, mission deep dives, and science that actually matters. Drop a comment. Do you think we'll ever fully protect astronauts from the sun? Or are we just learning to live with the risks? Until next time, stay curious, stay safe, and keep looking up.